matrix multiplication. So okay, and we'll go back to our exercise on Monday. Okay. Oh, that's here. Not here. That's from Tuesday. So if you go to week 6, lab 1, and for session 1, okay, matrix operations. If you go there, so now, remember we actually read 4 numbers from the user. Let me just remind you about it. So number of columns, so number of rows M1, and number of columns M1, and also number of rows M2 and number of columns M2. Let me just replace them on this example here to show you. Okay. So this is the number of rows M1, and this is the number of columns M1. And this one here is the number of rows M2. And this one is the number of columns M2. Okay, so now a question for you. If we want to do multiplication, what's the condition for us to satisfy in order to do it? What should we check? To say if this condition is true, then certainly we can do the multiplication. Do you want to say something?
Column number 1 is not equal to row number 2.
You meant equal, not really, not equal to. You want to check that this number here is equal to this number here, right? That's what you want to do. Yeah, so you want to make sure the number of columns N1 is equal to the number of rows N2. That's what you want to check. If these two numbers are actually equal to each other, that means we can do the multiplication. Otherwise, we cannot do it. Okay, basically checking that this here is equal to this here. Okay? And then, another question, but I will answer that myself. Another question is, what should be the dimensions? Let's say we can do the multiplication. What should be the dimension for M3? In that case, it will be the number of rows M1, and then the number of columns M2. Right? Okay? Because this number here will be cancelled out somehow. Okay? That's something for you to think about. So now let's do it. So now we said before, so this is when we check to see the number of rows and the number of columns are pairwise equal for the addition and subtraction. So now we're going to do another one. So we're going to say if the number of columns of M1 equal the number of rows of M2. If that's the case, that means we can do multiplication. Can do multiplication. Otherwise, we cannot do it. Otherwise, you can just print some error here. You can say system.out.println. You can say error. We cannot perform multiplication. Okay, so now let's see how we can do multiplication. In the case where the number of columns M1 is equal to the number of rows M2. Okay, let's see how we can do it. So first of all, we need to create a new array called M3 that represents the multiplication of M1 and M2. So now integer 2-dimensional array M3 is assigned to integer array new. Don't forget the new. Okay, so now the number of rows for M3 would be just the number of rows of M1. And the number of columns for M3 will just be the number of columns of M2. Okay, you might still try to get used to the variable names, but that simply just corresponds to what's defined in your handouts. So just make sure you study that after.
Column?
Number of columns of M2. Oh, rows. Good catch. Absolutely. Thank you. Very good. Thank you. Yeah, number of rows here and number of columns here. Okay, good. So now
we would like to fill in the slot for M3. So let's just do it first. Standard loop, so integer r equals 0, r less than n3 dot length, and r plus plus. Also column by column. So now integer c equals 0, c less than n3 at particular row r dot length. Okay, you should be quite familiar with this. We have done this many times. So now somehow filled in M3 RC.
But now how do we do that? Okay. Somehow we have to, for example, if you choose this row here and this column here, somehow we have to say 7 times 10 and 8 times 13 and add it up together. Okay. It seems like we just need another loop. Okay, so this might be the first time I'm going to do 3 loops. Next it, but just to actually make the example work. So now, first of all, tell me something. How many elements are in this row here? And how many elements are in this column here? They happen to be the same. But which variable do they correspond to? Correspond to this variable, right? Number of columns M1, or the row, number of rows M2, either one. Okay? So it seems like to actually add it up together, we simply have to run a loop, which will start from 0 up to this number here. And then each one of them is going to multiply the corresponding positions in the two things, and then add it up together.
Okay, let me show you how you can do that. So what we will do is to say for, okay, I would say in the handouts actually say Y, right? Column Y, the width. I would say Y here. Okay, just to make it a little bit more corresponding to your handouts. I would say integer Y, so that's a new loop counter, equal to 0, and then Y less than, we can say, for example, the number of columns of M1. You can either say this, or you can say number of rows M2, because they are equal. Okay, it doesn't matter which one you say. And then Y plus plus. Okay, so now somehow we have to do the multiplication, right? For example, 7 times 10. Think about this. Let me just use the red. 7 here is N 0. Oh, sorry, not 0. Let me just write it out for you. We were trying to calculate, let's say, M3. Let's say we have to calculate this one here, which is 2, 1. 2, 1. So this is defined to be, so you have to do M1, 2, 0, multiply by N2, 0, 1. Okay, I'll write it out and I'll show you how you observe the pattern. Plus M1, 2, 1, multiply, and 2, 1, 1. Finally, you got, oh, actually, that's it. One thing to note, you have 2 here, right? So that means you're going to choose row number 2. You got 2 here. And you got 1 here. That means you have to choose column number 1 on M2. Right? So now, for this one here, 0, 1, and 0, 1, it's like running a loop counter that will go from 0 up to the number of columns M1, right? That's what you would do. So that's how you observe the pattern. So that's exactly what I'm going to do. So now, over here, you can think about why this is the case, but I'll just give you the solution anyway. So you can say M3 R C. Oh, sorry, not yet, not yet. You got to do the addition. You can say integer, let's have some variable here. Sum is equal to 0. We have to add them up together. Sum is assigned to sum plus. So now here comes the critical points. We have to say M1 plus M2. Okay, so remember we have to choose row R in M1 and colon C in M2. And then for this particular part, it can just be Y. Okay. After the for loop, we can simply say N3RC is assigned to sum. And we are done. Okay, so it does require some careful thinking here. So basically, we're saying that we have chosen row R. So now our goal is to set M3RC to be some number. In order to do that, we have to choose row R for M1 and column C for M2. And somehow we have to multiply their corresponding position and then try to add it up together. And apparently I made a typo here. So this here should be multiplication. Okay. We should multiply the corresponding positions in the column in the row in M1 and the column in M2. Multiply them and add it up together. After that, we can assign the sum to RC in M3. Any questions? We're done for this one. Okay, maybe you can think about that. If you still cannot really get it, you can still come to my office hour. Or you can use a discussion board on Blackboard. Right? You can use that. So that's a perfect place. You can just say, well, I don't really quite follow what he was saying in the lab. And then you can say, can anybody explain? And then I'll actually watch how people explain the problem, and then I can actually help you get to the final solution. So make use of the discussion board on Blackboard. It's going to help you. Okay, after this, we're just going to print out what M3 is. The system.out.println. Okay, we're going to say N3 is follows. So we're just going to print it out. So integer r is equal to 0, r less than n3.length, r plus plus. And then we're going to do, let me be a little bit lazy here. Can we just copy this part here? Okay, like this part. When we did the addition, copy that, and I'm going to replace that. So M1 multiply M2. Okay, so now I'm going to say N3 here. That's good. Yep, we're done. Can we have a try and see what's the result for this multiplication? Let's give it a try. For M1, it's 3 by 2. 3 by 2. And then 1, 2, 3, 4, 5. Why would I actually jump from 5 to 7, I wonder? Yeah, it should be 6 and 7, but it doesn't matter. Okay, I was wondering, but that's fine. I'm going to follow that precisely. 5, 7, and... sorry, let me do it again. My bad. Do it again. So it's 3 by 2. Okay, 1, 2, 3. No. Certainly, I don't know. I didn't know how to count. 1, 2, 4, 5, and then 7 and 8. Okay, so that's exactly M1 on the board. So now let's do M2. It's 2 by 3. 2 by 3. And now we got 9, 10, 11, 12, 13, and 14. Okay, so that's the matrix multiplication. Okay, for example, we can double check 96 as we did before, and also 174 as we did before. Okay, it seems to work. So your exercise today is to go over this matrix operation exercise to study from that. Okay, I think that quite nicely demonstrate the how you can make use of the two-dimensional array, especially how you can run loops over that. Okay. Any questions before I move on? Oh, okay.